This is the video tutorial for Unit 1, homework pages 7 and 8. This was day 5 in our chemistry classrooms. It was September 1st for Red Day and September 2nd for Blue Day. So what we did today that was new was average atomic mass. Now average atomic mass, there's all these notes up here if you need to read these, otherwise you don't need to worry about them. But what's important about it is that this is a weighted average. Okay? So we're going to come down here and take a look at what that means. Calcium 40, it's an isotope because it says calcium with a mass of 40 in its name. It makes up 96.9% of calcium in nature. Please go ahead and circle those so you know that this percentage goes with this mass. 0.7% is found in calcium 42 form. So that means that less than 1% of the time, calcium can be the isotope 42, and then 2.4% of the time it's found in the calcium 44 ion. Now, I don't like how this works out where this number goes with this one down here, so I like to rewrite that, 2.4%, and then circle them so that I know those numbers go together. Please get in the habit of writing these all out and showing your work and your problems and labeling what's given and what's not. That's going to help you in math, that's going to help you in chemistry, it's going to help you in English, ACT, SAT, PSAT. Just get in that habit, please. The first thing we do for average atomic mass, and if you miss the notes or you miss a day of class, you can see them do that here, okay, is that we need to take our percentages and we need to convert them into decimals, which is really easy. So I'm going to take my 3 percentages, and you don't have to show this work, but I recommend that you do on your problems. 96.9% here, 0.7% from here, and 2.4% from here. Now we divide each of those by 100. Okay, so you take your given percentage, divide it by 100 equals your decimal. And now our percentage is in terms of decimals, so now we can do math with it. So this is going to be step 1. So if I divide those all by 100, and I just plop that straight into my calculator, guys. 96.9 divided by 100 is 0.969. I'm going to write that, 0.969. This will be 0.007. Okay? So check that out. 0.7 divided by 100, 0.007. And this one is going to be 0.024. Now what we're going to do with each of these masses is we're going to multiply, each of these percentages is we're going to multiply it by the mass. So 96.9% of the time, calcium is mass 40. So I'm going to do this times 40. I'm going to get an answer for that. Less than 1%, so 0.7, which is 0.007 here when we converted it, times 42 for this one. And then 0.024, which is this one, so calcium 44 isotope. So I'm going to do all 3 of those numbers, and I'm going to write down my answers. 0.969 times 40, 38.76. Okay. 0.007 times 42, 0.294, and then 0.024 times 44, 1.056. So now that I have these numbers, I just add them all together, and that's what they show you here. Okay. So step 1 is to convert our percentage to a decimal by dividing by 100. Step 2 is to multiply that decimal times its mass. Okay. And step 3 is going to be to add them all together. So I will go 38.76 plus 0.294 plus 1.056. My average atomic mass will be 40.11 AMU. So AMUs are always going to be your units for mass of atoms. We're going to go like that, box in your final answer, just like they show you up here. Okay. Now let's think about this problem, because I had a couple kids do this in class, where instead of 0.007, they just did 0.07, and they got an answer of like 52 or something crazy like that. And so I want to look at seeing why excuse me, let me see if I can get this a little more clear for y'all. Just a little bit more. How you know if you were right or wrong. So I'm taking a weighted average, but I'm averaging 40, 42, and 44. So my answer, in order to make sense, if it's an average of those, should be between 40 and 44. If you get an answer of 26, you did it wrong. If you get an answer of 52, you did it wrong. It needs to be between these numbers. And I can even use these percentages, so almost 97% of the time, calcium's in 40. So my average is going to be really close to 40, because that's what it is most of the time. And so if I get an answer of 40.011, yeah, that's about what I expect it to be. An answer that's going to be really close to 40, because most of the time, calcium is 40. So it's going to be a bigger part of the average. Let's turn it over and look at page 8. I want to do number 6 with you, and let's think about this one before we do it. So number 6 says gallium can be used in lasers. That's a fun fact. Cross it out. That has nothing to do with this question. It's called a distractor. Don't let us distract you. Okay? 60.1 of the atoms are in gallium-69 isotope form, while 39.9% are in gallium-71 form. What's the average atomic mass? All right, before I do anything, I want to think. I want to turn my brain on. I'm averaging 69 and 71. So this number needs to be somewhere between 69 and 71. It can't be smaller than 69. It can't be bigger than 71. So which percent is it most of the time? Well, most of the time, 60% of the time, it's gallium-69. So the answer should be between 69 and 71, but probably closer to 69. All right, so step 1 is to convert our percentages to decimals. So when I divide this by 100, 0.601. When I divide this by 100, 0.399. So I divided these by 100 in my calculator, and that's what I got. All right. Now you multiply each of those for step 2 by their mass, and that's why I circled them. So I know this number goes with that number. So 60.1% of the time, it's mass of 69. 39.9% of the time, it's mass of 71. So I'm going to get those answers for step 2. So let's look at it. 0.601 times 69, 41.538, 0.399 times 71, 28.329. So I can add those together now, plus 41.538. And I get, as my answer, when I add them up in step 3, 69.867 AMU, and I'm going to box in my answer. Now, does this make sense with what I said before I even started? Yeah, it's between those two. It's a little bit closer to 69 than 71 because a little bit more of the time it's as 69 versus 71. Wonderful. I think you guys had a pretty good grasp on that for those of you who are in class. Number 8 really threw people. And this table, okay, this data table, is what your test will most look like at least half the time, okay? So what's the average atomic mass for carbon using this data table? Well, they're saying the abundance is how often. So 98.93% of the time it's carbon-12. 1.07% of the time it's this mass. So we're going to do the same thing. We're going to divide them by 100 to make them decimals. So that'd be 0.9893, 0.0107. And be careful, a lot of times people put the decimal here. All right? That would be 10.7%. So let's just take a look again. 1.07 divided by 100, 0.0107. Then I can take my decimal times the mass, and this decimal times this mass. That's step 2 and get my answers. Okay? So I'm going to go 0.9893 times 12.000 gives me 11.8716. 0.0107 times 13.003, 0.139131. Then we add those bad boys up, plus 11.8716. Okay, 12.0107 AMU. So again, that's just what I would expect. Most of the time, my element, my carbon, is in the form of carbon-12, almost 99% of the time. So my answer should be really close to this number because this is an average. Most of the time, that's what it is. And that's what number 9 is asking you. Now, number 9 you don't need a calculator for. We just want you to think. If this is argon's atomic mass, and these are the 3 common isotopes, which one would have the highest percentage? So which one would have the highest percent abundance? Okay, which isotope do you think is most abundant in nature? It just means common. Abundant means common. How common is it? If this one is common 99% of the time. This one is common only 1% of the time. So if this is my mass, which one of these is the most common? And then try to explain why. Okay, this is one of those lessons that this made sense and you've got it, you totally understand how to do it, or you need some more help. So please make sure you're coming in. We have a test next week. So come in for tutorials if you're still a little bit foggy on how to do these on your own. Thanks so much, y'all.